Okay, as promised, here is the second example of using the standardized z-scores for normally distributed data. So we know how to calculate this, we know how to figure it out. We should know how to figure this out both ways, using the z-score and the table, and then using Excel with the normal distribution function. So this is a little different though, this problem. This problem is now asking not what's the probability of seeing something greater than this observation or seeing something less than this observation. It's asking you what's the probability of seeing between these two observations. So we're going to be looking at the area under the curve between two x values or two observations. I took the easy way out of this one a little bit. I'll explain to you why and how as we go along. But if you're really paying attention, you'll see how I saved myself some time on this. But whenever you have a question that's asking you, what's the probability between two numbers? More than likely, you're going to have to do the z calculation twice. Okay, once for the one, to figure out the area for the one number, and then to figure out the area for the other number. And then do some math in order to find that area under the curve, which again translates to the probability of seeing that. So let's look at the problem for this example and go ahead and calculate it. The weekly incomes of shift foremen in the glass industry follow the normal probability distribution with a mean of 1,000, which we have here. You can see the mean of 1,000. Nope, I don't want to do that. I kind of screwed that up a little bit, and a standard deviation of 100. So the mean weekly salaries, the weekly income for shift foremen is $1,000 with a standard deviation of $100. What is the probability of a shift foreman in the glass industry earning between $790 and $1,000? Now, this might be good information to have. Let's say if you're in human resources, and you say, okay, we have a shift foreman job coming up, or maybe we have something with the union and we're trying to negotiate, and we say, okay, what's the probability of shift foreman maybe earning between this and this? And we're going to say, well, a low of 790 and up to $1,000. What's the probability of seeing that? So all we really have to do is plug in our numbers for the z-score. In this case, we'll plug in, we'll figure out for 790, which is our observation here. So it would be 790 minus 1,000 divided by 100. And I'll just do that down here so equals 790. And don't worry that it's going to be a negative number. We are moving kind of from the mean in this direction to this point. So it's, in essence, it's negative. Minus 1,000, and I'm going to put parentheses around those two because I want to do that function first. And then divide that by the standard deviation, and we get 2.1. Now again, just ignore the minus sign. That's just saying we're moving to the left. But so we have a 2.1 as a standard deviation. So this 790 is 2.1 standard deviations from the mean. So if I were to just put it in standard form here, we have a mean of 0 and a minus 2.1 standard deviation here. So that's pretty far from the mean, right? We know 2 standard deviation, that's getting pretty far from that mean. So we would assume the area under the curve here is going to be a pretty big proportion of this entire thing. So let's go to our z table. And again, ignore the negative. We go to 2.1. It's 2.10 again. So just like before, all we have to do is go here. If it was 2.11, 2.12, 2.13, we would just keep moving along. But it's 2.10, so that's, and we thought it would be pretty big, 48%, a little over 48, 48.21. So this area under the curve is 48.21, 0.4821 or 48.21%. Okay, so the probability of a shift foreman earning between $790 and $1,000 is just under 50% of the time. So just about half of the time, your shift foremen are going to earn between this amount. And that makes sense because 1,000 is the average, right? The average shift foreman makes that. It's by no means the top of the line or the most they can make. 1,000 is the average that they make, and about 50% of them make between 790 and 1,000. Now, if you're negotiating with the union might say, well, that's not good enough. We're still looking at less than half of all shift foremen make between that amount of money. If I were to add the 50% to here, I would say over 98%, 98.21, 98% of foremen make over $790. So I certainly wouldn't come in and say, okay, my shift foreman will make less than $790 because almost 98%, almost 100% make over that. So just by looking at the numbers and looking at the proportions in the areas under the curve, you could tell what percent of the population are making certain amounts of money. So let's go to the second part of that question, and we'll say what percent are making between 790 and 1,100. Now again, if you're sharp, I'm going to put this down here. And I know a lot of you are. That's probably about there. 1,100 is one standard deviation above the mean, exactly, right? If it was 101, I couldn't use it. If it was 102, I couldn't use it. But it's 1,100, and with 100 being the standard deviation, I know that this is exactly one standard deviation above the mean, right? Does everybody see that? If I take the mean and I add $100 to it, it gives me 1,100. That's exactly one standard deviation above the mean. That's what the number we're looking for. That makes it a lot easier for me. Now, if this number was 1,150, say, you would have to plug it into the Z, go get the proportion and do that. But being that we know from the empirical rule, one standard deviation above, right, this is going to be 34%. Let me just check real quick. I want to make sure it's 34.13. I might as well be exact with it. So one above and one below is a little over 68%, 6.6826. So I know that from here to here is going to be 34.14%. That's just coming from the empirical rule and something that we covered in another lecture. So now if I just take these two numbers and put them together, this area 4821 and this area 3413, I get 82.34%. 82.34%. So if I'm sitting down negotiating salaries for my shift foreman in the union or something, I could say, look, 82% of shift foremans in the glass industry make between $790 and $1,100. That's a big percentage, right? I would say, look, our guys should be making at least between that or somewhere in that area. We don't want to see them making less than $790 because we know about 2% make less than that, and maybe something over $1,100 might start getting a little up in the upper end of what people are actually earning in this industry. But again, we could pick any two numbers there: 800 and 1,200, 850 and 1150, whatever numbers we decide. We could figure out the proportion or the area under the curve, and that translates to what percent of the population is seeing these observations between these two numbers, or less than this number or greater than this number. So this Z value calculation and understanding standard deviation it means really can give you a lot of valuable information. So you could use it for anything at all. What's the probability of somebody waiting in line more than 6 minutes, right? If you have all this data gathered, what's the probability of somebody waiting in line 6 minutes? I'm sorry, that's a bad way to say that. You can't say right at the number. You'll never figure that one out. What's the probability of somebody waiting more than 6 minutes in line? What's the probability of somebody waiting less than 6 minutes in line? What's the probability of somebody waiting in line between 3 and 6 minutes? What's the probability of this item being out of stock in 5 days or more? What's the probability of this item being out of stock in less than 5 days? So if you have the data and it's normally distributed, and that's important, this for these calculations, it has to be normally distributed. If you have those numbers and it's normally distributed, you could plug in any observation X and figure out the probability of something happening. So that's very powerful. It's very useful. And I'll certainly give you some practice in the course room with some example problems or assignment problems, so you could work on these. But it makes for a great way to analyze data, right? And that's what we're doing. We're analyzing the data now, part of that DMAIC, analyzing the data and really trying to pull as much information so we can make inferences about our population.